Okay. It's Friday. Yay. It does. I also want to bring your attention to the fact that we will have our first quiz next week. Okay. I believe Wednesday. Okay.
Wednesday's a late.
It'll be fun.
I love math.
Yay, math. Okay, so these two terms right here, a postulate and an axiom, they both mean pretty much the same thing. These are considered a rule that we accept without proof. Going to be a trigger word for you, the word proof. When we get into chapter 2 and throughout all of first semester, a lot of what we do in geometry is proving things to be true. Okay, mathematicians, we prove things that are true. Now there are some things that we just accept and we can't prove. Okay, like the sky's blue. Okay. But when we get into more of chapter 2, we're going to have something called a theorem where we'll be able to put proof to the rule. Okay. All right. So we're going to work with some line segments today. So first of all, let's talk about what a coordinate is. You have a good way to describe what a coordinate is?
Spot based on numbers.
Okay. A number that corresponds to a point. What about if I ask you to describe what distance means? I have two coordinates. How do you know how far apart they are?
The distance is how far apart something is.
Okay.
You can find out the distance by basically taking the bigger number is subtracting it by the smaller number, and that's that's not it.
Well, I like the subtraction piece.
Subtract the bigger number by the smaller number, that's about the distance.
What if I have a -5 and a -10?
It's like the amount of space in between the numbers.
Okay, the amount of space in it. So I like the subtraction piece. So, okay, we're going to subtract our coordinates to get the distance in between. Okay, but what if it's a negative number? Can we have negative distances?
I mean, negative means it goes down, like maybe you add.
Not add, I like the subtraction piece.
But what if we could like if it was on a graph of some sort, it could probably go up and down with the help of negative numbers.
Okay, I like the difference of the coordinates, but my concern is, what if I have a difference that's negative? The answer is literally right in front of you.
Stay positive.
X.
Oh, X.
Lines.
Oh, X,
Lines.
absolute value.
Thank you.
Lines.
Oh.
W.
Stay positive. Because what does an absolute value do?
Makes everything positive.
Man. No, it's the opposite if it's negative, but it's not opposite if it's positive. Distance is always positive. Okay, today we're gonna talk more about distance when we are in, like, just one dimension, I guess. Monday, we'll talk about distance, on the coordinate plane when we, when it's not just a, not something we can just count with, the grid lines, okay? Now, congruent, have you ever heard the word congruent? You have? What does it mean?
That's adjacent.
That is adjacent.
Not next to each other.
That's not adjacent. So congruent segments would be line segments that are the same length. Good job. Thanks for your help. Okay.
Like, sort of over the
I would not say so, no. Line segments that are the same length. Okay, so we have some notation that we need to learn with this congruent stuff, okay? And we're gonna be talking about this congruent concept the whole year, okay? So I want you to turn to page 10. Okay. All right, so first of all, this symbol right here, I'm going to zoom in. This symbol right here is our congruent symbol. It's an equal sign with a squiggly over it. Okay, that means congruent. Okay, so here I'm going to point this out right here. Okay, when there are no lines above the segment, then we're talking about its measure. How long is our segment? Okay, so AB is equal to CD means our lengths are equal. Okay, over here, when I have our segment notation, we're talking about the actual segment. And so congruent means these segments have the same length. Okay, and we notate it by these little tick marks. Okay, so here's segment AB and segment CD. So do you see how they both have this tick mark? That is the notation for, hey, those are congruent. So I want to draw a picture underneath for us to kind of get an idea of what's going on here. Okay, so I want you to draw this segment. Hold on. There we go. This is segment AC. It has a point in between called B. And this is segment DF. And there's a point in between. And then I want you to mark it up like I have up here. You do?
Well, I mean, it is for the transition.
Yeah.
Oh, yeah, transition.
Okay. So what do these marks mean? since AB and EF both have just that one tick mark, that means that AB with this segment is congruent to EF. Okay. Also, since BC and DE have the two tick marks, that means those two segments are congruent. Now, if your diagram doesn't actually have that information, it just looks like they're the same, we can't assume anything. In geometry, we cannot assume. Okay, we have to be able to prove that things are actually the same. Okay, it can't just look like it. It can't look like a right triangle. We have to show it's a right triangle. It can't look like they're the same length. We have to show that they're the same length. Okay, now I feel like this next postulate we're going to go through, I feel like some of you might feel like maybe it feels like common sense, like, oh, I probably would have done that even if you didn't tell me to. Okay. So this is the segment addition postulate. Basically, if we have a segment where we have a point in between the two endpoints, we can say, okay, segment AB plus segment BC equals the whole segment AC. Okay, so maybe if you want to draw attention to this right here. Okay, so if we have a point in between 2 points, okay, so in this case, B is in between A and C, then we can make this an addition problem. Little chunk AB plus little chunk AC equals the whole segment AC. Okay. We're going to draw a picture down here with Q, R, S. Okay, so if there are little numbers hovering over a line segment, it's referring to the length of the line segment. Okay, so notation wise, this picture is telling us that QR has length 5. And notation wise, this picture is telling us that RS has length 7. Notice how when I'm talking about the length of the segment, I'm not putting the little hat on top. There's not a little line on top when we're talking about the length of the segment. Okay. Now, Harvey, how long is QS? Would be 12. Okay, because 5 plus 7 is 12. There's one.
Yeah, but how do you is to begin with?
It will tell you the information you needed to know to find something else. So like that picture would have been given to you with everything in blue. And then in red is what we did from the picture. Are you with me?
Not really.
So like this picture would have been given to you with the 5 and the 7 already written in. So then we could find QS using those numbers.
So couldn't we just add those together and take the two endpoints, then basically put that together and put 12 afterwards?
So that's what we did right here. So we did right here. So what I want you to do is I want you to go back to your math folders that most of yours are red and turn to page 6. Right. I want to know the length of segment AC. I'll highlight it in red. Here is segment AC. It starts at -6. It ends at 2. Nora, what's our length there? 8. How did Nora get 8? Pretty much 6 plus 2. Okay. It takes 6 to get to 0, and then there is 2 more. Okay. All right. We have segment BD. Segment BD begins at -1, ends at 5. Sam, how long is segment BD? You agree with Sam?
Yep.
Awesome. Segment CD. Brayden, how long is segment CD? 3. And then Presley, what about BA? 5. Okay. It was not trick just because BA is written backwards from what we probably would write it. We like to write AB. Still a positive difference. Okay.
What did you numbers ever make a determine negative distance?
Nope. Distance is always positive. Always positive. Okay. All right. So now what I want you to do, I want you and your elbow partner or elbow partners to work together on finding the X in this picture. I'm gonna give you 1 minute and then we'll do it together. See what you can do.
ST is 17. It's really. I was only using one.
Yeah.
Yeah.
You already have it.
Yeah.
Oh, it's what I was like.
Yeah, I want to know what X equals.
Last year was 2.
Or you can make an addition problem that equals something. Okay. All right, what did my trio of Alexa, Alex, and Nora get? They got X equals 12. Does anybody disagree? Okay. My suggestion would be if I have a line segment and they're giving me some measurements, I'm going to label my picture. RS is X. ST is 17. And the whole thing, RT, is 29. So I can visually see, X plus 17 equals 29. What do we have to do? We had to take 29 and subtract 17. Well, there's the equation that I set up, right? Okay. The reason that I'm going into this much detail for this example that most of you just did in your heads is because, go to page 7, sometimes there's going to be a little bit more algebra involved. Okay, so please do this with me. Please label RS as 3x. Please label ST as 2x minus 6. And then please label ST, the whole segment, as 24. Okay. What are we going to have to do? What can we write given this? So our two segments, so our cute little segments, 3x plus 2x minus 6 equals the whole thing, 24. Hey, we know how to do algebra, right? 5x minus 6 equals 24. 5x equals 30. So what's x? Okay. But here's the deal. When I am looking at your quiz on Wednesday or a graded homework assignment, whenever that is, I need to see this that I highlighted in yellow. I want to see the equation that you set up to get to your answer. Okay? Okay, that is showing me a lot of work. You wouldn't have to show me like the +6 and then divided by 5. We graduated past that. If you want to show me that, you go for it. But those are things that I think at this point you could do in your head. I even think that we're at the point that you could go straight from the yellow to 5x equals 30. Right? Yeah. Okay. All right, last example. Could you please plot those 4 coordinates? And label them, like when you plot J, label it J. Well, I connected JK and I connected LM because the question is determine if JK is congruent to LM. Well, in order to do that, I want the segments. Okay. What is the distance? What is the length of JK? Can we count it? It's 5. Okay. Notice how when I write JK equals 5, I don't have the hat on it. There's no line segment notation because we're talking about just the length. What about LM? Oh, okay. So since we know that JK and LM have the same distance, then we know that the line segments are congruent. You're gonna want to get used to explaining yourself, yes. Okay, at the very minimum, going from here to here, all right? But I need a little bit of context how you got here. I can't have picture to just, oh, they're congruent. You need to actually give me some information. Okay. All right, so we have a few minutes to where you can begin. Your homework, if you turn the page to page 8, your homework is on both pages 8 and 9. Okay, so you can decide what you want to get done here in class. I know we only have like 3.5 minutes, but pages 8 and 9 would be your homework for the day, weekend, whatever.